Hello there, welcome back to Technology Innovation Hub. So it's going to be the 13th session on Oracle non-multi-tenancy architecture journey. Let me share the screen. So we have been discussing this document and we studied the basic processes, PPID and the threads. So let's continue from here, the top command. So that is where we stop. The top command. So this will help you to understand more details, the subject matter comprehensively, because the top command also goes closely with processes and system statistics, the memory usage and all. So if I just type the top command, now you see I'm just typing without any parameter, just typing the command. And this is the current time, and it is up for this much of time, and 1 hour and 5 minutes. So number of users connected. And this is the most important one on this first line, the load average. So it will tell you as of last 1 minute and 5 minutes, 15 minutes, what is the load average. So that is what it says. And but you need to understand what the real meaning of these three numbers, the load average, because let me show you the document. I think I have explained that one. Yes, it is there. These numbers are average of the system over a period of 1 minute, 5 minutes, and 15 minutes. That is clear. And the first one, between 0 to and 1, there is no need to worry, because so if the averages are between 0 to 1, now in my case, I don't have that much of load here, so it is 0 to 1. So that means your system is not so busy. That's what it says. Your server is safe, but it's going beyond 1.5. Queue is just aggregating, and its queue is just becoming large, filling up. If the average gets higher, things are going to start slowing down. That is how. So this is a little bit of a warning song. But if it is 3, means more than 3 or going above 3, that means it is running out of resources. So the queue is filling up. So it's kind of, we need to either think about plugging more resources. So these averages. So that's what it means. But more we can understand in this way as well. You can see if the average is 0, that means the system is idle. But at the moment, in my case, it's not 0, but because the database is running, certain other processes are running, so it's not 0. But this one, the second value, you can see if the average 1 minute average is higher than the 5 minute average or the 15 minute average, that means load is increasing. So if the 1 minute average is higher than the 5 minutes or 15 minutes, now in this case, in this example, 1 minute average is higher actually. Yeah, this is the 1 minute average, and this is higher than these two. So that means what? That means the load is increasing. So in my case, currently, what is the situation? So anyway, it's like now this is lower. C is going down. So 0.5. That means load is decreasing. So if this is not much significant, because there is not much load is running in my system at the moment, but in the production, if you can look at it, so that is how you should read the value. And further, we can see if the 1 minute average value is lower than, that means your load is decreasing. So if that is the example in my case. So this value is lower than these two, that means the load is decreasing. So that is kind of a reading you can see. But now it increased. So, and now it's decreased. So like that. So all the point of period of time you need to monitor to get an idea about what's the statistics in the system, what is happening as of now. And you can see if they are higher than the CPU count, then there can be performance issues. So in my case, I am having 4 cores. So that means these values are going beyond 4 anyway. Right, 3 and all. So that means definitely it's going to be a performance issue. That means the system is running out of resources. So that's how you should read this value. Anyway, I have given this line for you. So this is for you to get an idea how you should read the load average value. But it depends. So that's why, because it depends. Anyway, you can get an idea from these things. Fine. And again, you can see the output further. You can read it. Here it says the memory, what is the CPU usage. You can see a user space, system, CPU usage, and priority. This is very important one. Idle usage. ID is idle, and at the moment my OS is 94% idling, because there's not much value my processor is 94%. So that much, I mean, this database is up and running, but there's not much workload in the database. So therefore it's 94% idle. So that is what idle percentage. And I think again, these values I have given here, the meaning of each and every I have given here, you can see US means the amount of time CPU is spent executing in user space, amount of time kernel space, that is SY. NI is the nice value, the priority CPU. Priority we can adjust amount of time for idle time, that is the ID, that is very important one. And this is waiting, hardware interrupts, and now you can just read it. And again, I have explained the rest of the latter part as well. That's interesting thing. Now here you can see KIB. This is the memory is given, total memory for this system and the pre-memory in the system. This is in kilobyte, no, KIB. So KIB, kilobyte. So let's say I want to take it in megabytes. How can I do megabyte, gigabytes? And you can see, yeah, if I press capital E here, just watch this column here, it will get changed. You just keep an eye on this column, it will get changed when I am pressing capital E. See, now it's in megabyte. So my this is a virtual machine I am running. So guest OS, it is having 10 gigabytes. So this is in MB. So in GB, again pressing E will change it to GB. You can see 10.5 GB. Again pressing E will take it to terabyte. So I don't have that much. And it goes, the cycle goes petabyte, PIB now, and exabyte, and likewise. So that way it will change the display, and again it will come back to kilobytes. So like you can press capital E. I have given that explanation in the note as well. And on the down, the process ID, user, and you can see again I have given the explanation for that. Priority and nice value and virtual amount of virtual memory and amount of resident memory used by the process. Yes, you can see an amount of shared memory, like status, process status, and I have given the status as well, like running, sleeping, zombie, likewise the process status. So you can see most of my process status are having a value of what is the value? Status. This is running and now becoming SSS. This is running. Oracle process is running, and this is the top command. So likewise. So depends on the scenario situation, it will change the value, and likewise. Fine. Yeah, these uninterruptible sleep. Fine. And so that is about status column and the CPU usage. Again, you can see here the memory is given in M, no, that is in megabytes. So if I want to see it in gigabytes and also I can change it. These values are in M, no, M, memory is M. And if I just press simply here, earlier it was capital E. Now pressing simply will change. See, it's went to gigabyte and terabyte and petabyte. Now it's coming back to kilobytes, and now it's changed into megabytes. So like this, I'm just pressing simply. Earlier it was capital E. Right. So just to get an idea about the top command, and I hope it is useful to you. And so those are the, just to give you an idea about the processes, threads, parent process IDs, and about the values, how to read the load average and not from the top command. And fine. So let's continue. Yes, I have given this explanation, change numerically, you can go through it. As step 5, let's take a look at about that parameter, threaded execution parameter. So that is the parameter that we were discussing initially and introduced in Oracle. In you can see I have given 12.2, because in 12 only, not 12.2, in 12C only Oracle enabled that multi-threaded feature to the database. So they introduced this parameter, threaded execution, whereas by default this parameter is disabled. Disabled list is not true, it is false. So let's connect to the database. If I just type show parameter, and see the value of it is false. This is the default value. It's the default value. And if I just take a look at from database side, yeah, we can do some column formatting, and this is to check the PID, process IDs, and thread IDs at the database level. because we were checking this at the OS level. So we can take it from the database level, shadow process ID, and we can get the thread ID. Yes, thread ID, shadow thread ID, and yeah, let's format those columns, otherwise it don't appear. Can use SQL developer, but I'm just using this SQL command line. We use SQL developer ID as well. Okay, let's try it. Yeah, so this is what. So at the moment, same information given at OS level. This is from database. We can put a select command and take. So you can see the same information. Shadow process ID, shadow thread ID. And if you take a look at that, OFS will have the, that was having multiple threads. You can see that even a general task, it was having multiple threads earlier, and here also should display the same. You can see for 62 process ID and the thread ID is different. So that is how it shows here. For others, it is same 60, 60, 57, 50, because it is having only processors. There are no threads running. But here we have multi-processors because we noticed that one at OS level. File server had the 2 processors. Similarly, we have, that's why the process ID and the separate thread ID is there. So fine, just to get the details at database level, and further we can go here. Yeah, and you'll notice about threads running except, yeah, that is the general task and the file server. I just explained that one. And now what we can do, our parameter is false. So at OS level, we looked at this one earlier. So at OS level also, we looked at the number of processes. We can take a look at it now, but ps minus ef grep. So you can see, let's take a look at it. At OS level also, the parameters, we can take a look. We can exit from here. And this is the current situation at operating system. You can see Oracle processes are running, same output as earlier. And this is EL means the processes are given, and thread PID and process ID. You can see again, general task will have, yeah, now this will show the process ID and the thread. Now there are thread information here, parent process ID and PID, because I'm just looking at EF command. So thread information won't be there with the EF. And but you will see for general task 1, general OFSD, we have OFSD, OFSD, there should be another one. Anyway, so okay, we can see it much clearly if you look at the threads. So we look at the threads first. Yeah, this is, it doesn't show the threads, no, so that's why only the process ID is given. Let's look at this one. I think simply you can put a L here in between. If you put a L, it will give the process threads as well, both. Now you can see the thread ID and the thread count. You can see too. So this information we got it earlier. We know that, but you can see this is without enabling multi-threaded parameter, because currently you notice the multi-threaded parameter was false. So without enabling multi-threading, you can see Oracle by default having multi-threading only for general tasks and OFS. Now we need to see, once we enable multi-threading, what's going to happen. So that is what the practical is going to show you. So let's enable multi-threading in the database and let's see what's going to be the change. So let's do it like this. I'm going to make it true. So let's pause. This will enable that one. Yeah, so you know this one, because enabling this parameter will disable OS authentication. So I have to give database authentication or different type of authentication. So now I can say show parameter. We studied this one at the very first session on this multi-threaded. I think session 10, we have explained that behavior. Threaded execution will tell you now it is true. Right? So now it is true. Now what we can do? Now go back and check that number of process. Just watch closely. what has happened to the number of processes? Let's see, I am just running ELF, not the ELF. First we run the EF command. ELF will give you the thread details. No, let's check the processes first. So look at that. Drastically it has reduced. Earlier, you saw a whole lot of, I think, earlier, originally, we had around more than, I think, 54 processes were there. The output here you can see in the document. Without enabling the multi-thread parameter, ps-ef command gave 50, around this much of, more than 50 lines are there. But now, after enabling that one, see what has happened, it has gone to reduce. It has reduced very highly. So that is what happens. The reason is, you can see it has increased the threads. Now, if you look at this one, the processor usage, the column C is higher. Earlier, it was continuously 0. But by enabling this particular parameter, the thread system, what it has done, it has grouped the process. So group the process in a sense, it has created multiple threads per process. So now this particular process is going to have many threads within that one. So that is how it's going to be. That's how it has reduced the number of processes. So as a result, the CPU usage has become high, but overall CPU usage will go down. Now, let's check that one. So how do you check that? So we need to see ELF. So if you look at the process details now, sorry, the thread details, ELF will give you thread details. Now look at that. This is EF, no? So this one give the thread detail. This is only the process details. Now ELF will give the thread details as well. So now you can see, you take a look at that. Now number of the thread, this is the number of threads, has gone to 9. Earlier it was 2. I mean, only the general terms and OFS had 2 number of threads, but you can see now thread count has gone high. 9 threads it has, right? And here the number of threads under this particular process, this one, this particular not 2 particular process is having this much of threads. 902, 902. So that's the processor ID, but it has having 62, 63, 77. Likewise, there are 9 processes for that. And further, if you take a look at it, the U006 having 45 threads. So that is how. And this one goes, the process ID is this, and the thread IDs are same process ID. See, same process ID, same process ID. Thread IDs are increasing. Different thread IDs. 74, 75, 77, likewise. So it has 45 threads. So that is how Oracle is going to change the behavior, and it will introduce threads after enabling that multi-threaded parameter. So you notice the difference. Anyway, overall, this is going to increase the performance. It will reduce the processor usage and memory usage, because you know what will happen. When you have many processors rather than threads, there's something called context switching. I think I have explained that one. Context switching is when the CPU want to switch between from a task to another task, switching between tasks. If you want to switch from task 1 to task 2, it has to save the values, the registry values, whichever doing within the process, it has switched to the other task. That means switching to the next process. So that is context switching. So switching, if you don't have threads, this is what happens per program. If you have processes, so we have to do many context switchings as demand comes, as the scheduling happens. So by introducing threads, what we can do, we can reduce the context switching, which will heavily increase the performance, and the resource usage also it will drop down. So that is what Oracle is attempting here. I think I have explained those things in the note. Yeah, so same thing I have explained, what I just explained here. You can see we can get this one. This is PID stats, process statistics we can get. Yeah, this is interesting one. Let's take a look at this. Why we need this? Because now this is kind of a group in threads. No. Now, if you want to see, now let's say I have this group. What is my thread ID? So no, what is my process ID? This is my process ID, no, 9062. And I have 9 threads on that. Count is 9, count is 9, thread count is 9. So if I want to expand this group with more details, this is only giving the thread ID, no. I just want to see the memory usage and more details. So that is what is done here. You can see what is this PID stat -3 minus thread and process. 1570 is this. What is 1570? 1570 is U000. It has, as per this output, it has 17 threads. So I wanted to see more details in that thread group. This is a thread group now because it has hidden threads. Within this process, the threads are hidden, 17, because this is the PS minus EF output. It has hidden threads within them. I mean, ELP output will give the threads, but I want to see more details. So let's take a look at it. I want to expand, elaborate this particular process ID. So what I will do, what is my process ID? I'm going to elaborate. Let's elaborate this one. We have 9 threads here, no? 9062. So let's do that. We can do 9062. -3 is thread, minus P is process, 9062. Okay. Now you can see what's the output. Now this is expanding the threads which are hidden within this particular process. That is what. And PS minus EF grep command, this command, we have this 9062. 9062, yes, that is what. It is a process ID. It has hidden threads within that, and I want to elaborate it. And once I elaborated, now you can see this TGID means a group thread group ID. Yeah, it is a thread group because it has hidden threads within that. Right, thread group ID is that, and this is these are the threads which are running in that thread group ID. I have this much of process. There should have been 9 processes, no? So sorry, 9 threads. There are 9 threads, and these are the processes running, or the lightweight processes running within those threads. Background process, even system order checkpoint is there, the critical process. So those are running as threads, and per thread the CPU usage is given. You can see how much CPU is used in this particular thread, and system usage and the usage space. So this is very important statistics, because enabling threading system, I mean, will force the administrator to find more details which is about the hidden threads at OS level. So this command, PID stats command, is a vital command to use in that case. And further telling you even the kill -9 command will not be working here, because now the sessions are also given different threads, because kill -9 command will try to kill the process, no? But there are sub threads. There are threads running within the process. So Oracle handling those things are differently. So we had used kill -6 command. Anyway, so those details we will take a look at later. Here I just want to explain the behavior of the thread parameter, enabling threaded execution, what is going to do. And further, you can see I have given that command again. Yes, this command we ran it. And similarly, we can again take a look at the SQL level as well. That is fine. And I think I have some commands here. It will help you to find more details. Yes. The whole objective is multi-threading system. The whole objective of multi-threading system is to reduce the resource consumption and optimize them, and also reduce the context switching. That's what. Resource consumption and optimize and context switching. I mentioned this one. Okay. Fine. The whole objective of multi-threading system is to reduce the resource consumption and optimize. Yes, optimize the resource, optimize them, and reduce context switching. Fine. So there are impacts like listener behavior as well as which discussed later. Yes, because enabling multi-threading, now there are impacts. You saw OS authentication was disabled, and there are different behavior in listeners as well. the listener how it works. It getting deep. There are certain changes. We'll understand it later. And to further, if you want to get more detailed at the OS level, I can run this command. Let's run it and see. Yeah, see, now I can't do OS authentication because I have enabled that parameter. So therefore, I had to use DB authentication. And if you look at, select pseudo process ID, thread ID, execution type, process name, and I am just filtering out where it's not null and filtering out execution type, process, and process name like this one. So you can see execution type. Now this process ID and thread ID, and you can see this is a thread and this is a process and thread. So we can filter out like that. So same information earlier we saw, even this memory monitor and those things are running as thread at OS level. So it confirms here. And again, system monitor also was a thread earlier. So that was confirmed from this output as well. So you can see SMON was a thread. So it is grouped under 9062 and it is a thread. You can see again at the database level also the same thing is confirmed. Yes, so that is what. Okay, and the same process ID 9094, SMON was running 9094, and this fellow also gives the same thing, SMON 9094. Yeah. So that is at the database level, and further there's another command I have given. This command, let's take a look at. Copy this one and run it. Yes, so this is giving the overall count. Yeah, select execution type, server, and from processors visualization. Yes, how much of threads are running, how much of processors are running. You can see number of processors 4, 31 threads. Execution type, server, and because I am having dedicated connections. There's a default connection, or there are no shared connections here. So either threads or processors, those are dedicated. But I am having 31 threads at the moment, and processes 4 as of database level. Fine, right. And why I am not digging further details on this threaded parameter, because it is kind of new, and at the moment it is perfectly working up to 19C. It was perfect. It not, we can't say perfectly. It is working with Linux and Unix Solaris systems. But now with 21C, Oracle is coming back and they are telling, you can see if you look at this documentation, it is available in Windows as well. If you go to this documentation, yeah, so this is 12.2. Yeah, that is where they introduce it. No, 12 point. This is 21C. Database 21C. Yeah, this is what. So release 21C, the latest release, threaded execution parameter. So they have updated the documentation telling now threaded execution on Unix and Linux. So this was there now, but threaded execution on Windows. Now they are telling, starting with Oracle 21C, threaded execution initial parameter is supported for databases running on Microsoft Windows. So now they are telling it is supported. Yes, it is supporting. On database parameter set into true, likewise, so this is the same explanation. Now starting on 21C, it is supporting on Windows as well. On such the databases, the parameter must remain set a default value true. Setting the parameter of all database running on Windows is not supported. So that is another thing, because what they are telling me, is supported for the database running on Microsoft Windows. You cannot change it to false because on such database the parameter must set to its default value of true. So anyway it is enabled because we know Windows is different. No? Windows anyway is running it multi-threaded system by operating system. That's the nature of operating system. So we need to link it to the Oracle level with multi-threaded database feature. So we need to leave the default value. That is what they are telling. Setting the parameter to false on database running on Windows not supported. So that's what they are telling. So you need to leave the parameter as it is if you are using, but anyway what they are doing is by default the feature is enabled from 21C. So Oracle is coming back with this parameter because this parameter was not heavily explained from this introduction. I mean they introduced it on 12C, but 18C, 19C they were maintaining the same documents. Even if you look at the documentation you will realize that but now with 21C they are coming back in more details with this parameter. Now this one is database reference. Now further I can tell you these details as well. This one, this documentation is the administration reference. Administration reference, and which is not yet available for Linux and Unix. 21C, it is available for Windows at the moment. So this is database reference for Microsoft Windows about thread-based architecture. So we will get more details about this later because it's 21C. We are not touching 21C yet, and it is only available for Windows at the moment. This explanation, this particular reference is available. I'm telling about documentation available only for Windows. And if you go back here, it is 21. This is where we are. If you go to books, take a look at books, and this one, Oracle Database 21C, Administrator Reference Guide for Microsoft Windows. Only Windows reference guide is available at the moment. So Oracle will publish the Linux and Unix guide, whereas if you take a look at other versions, they have you take a look at 19C, and if you go for books, they have the administration reference for Linux and Unix as well. So let's take a look at that. This is 19C, administration reference for Linux and Unix base, administration reference for Windows. This is 19C. Whereas in 21C, Oracle has released the reference guide only for Windows, the documentation reference. So let's wait till they release it. And that's why this parameter, it has a future. That's what it means. So anyway, Oracle, this is a valid parameter and it has a lot of resource savings at the OS level as well as database level. Okay, for the time being, I think it's enough of explanation about that parameter. And I think you got a detailed idea about the Oracle multi-threaded systems and the process IDs, parent processors and threads, and how the behavior at OS level as well. So I will upload this document as well, so you can refer it. Okay, so if you like the video, you can put a subscribe. So thank you very much, and I'll meet you soon. Okay, have a nice time. Okay, bye bye.